Okay, everyone, so today we are going to focus on Investigation 4.4, which talks about the difference between irrational numbers and rational numbers. So I already have the notes here for you and even on your sheet of paper. So it says that an irrational number is a number with decimal representations that are non-terminating and non-repeating. Some irrational numbers can have a pattern, but some might not have a pattern. So basically, in simple terms, they go on and on forever and do not repeat. Another example of an irrational number, so it's basically any decimal that goes on and on and on, but they do not repeat. Like I said, another example would be any non-perfect square. So I would definitely write that down if it were me. All non-perfect squares are irrational because, for example, I'll write it up here, the square root of 17. If you find the decimal representation of that, it would go on and on forever and the value never repeats. Another example, any, like I said, non-perfect square. The square root of 80 is irrational because if you would find the decimal representation of that, it would once again go on and on and on, and it would never repeat. Rational numbers, on the other hand, they end or terminate, and they also can repeat. So any number that terminates, ends, or repeats are rational numbers. You can also note that all perfect squares are rational. So think back. The square root of 16 is rational because the square root of 16 is just 4. 4 is a whole number, it terminates. Also, the square root of 64, or excuse me, the square root of 36 is rational because the square root of 36 is 6, and that is just a whole number. We also talk about real numbers, and they're just the set of all irrational and rational numbers. So in this example down here, I'm going to change the directions a bit. It says, in the two examples below, identify which one would be an irrational number and which one would be a rational number. So, for example, A. And I'm going to add a dot, dot, dot at the end. So example A. If this value would go on forever with a dot, 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 and if I take a look at my digits, 14159,265, those are not repeating. So this right here is an example of a non-terminating, non-repeating decimal. So this would be classified as irrational. Letter B, however, is just a whole number. It stops. Therefore, this is rational. Moving right along. So here we have 12 different examples. I basically want to know if the values are rational or irrational. So this unit basically deals with a lot of memorization and not so much math. You have to memorize what the difference between irrational and rational would be. So for number 1, square root of 7 is going to be irrational because the square root of 7 in your calculator would go on forever as the decimal and would not repeat. This is also a non-perfect square. The square root of 16 is 4. That is rational because it's a perfect square. It's also just the whole number. If I have the square root of 4 times the square root of 4, well, you know that 4 times 4 is 16, and the square root of 16 is just 4. Since 4 is a whole number and it terminates, it is rational. Number 4. If I take the square root of 7 times the square root of 7, well, 7 times 7 is 49, and the square root of 49 is just 7. Since that number is a whole number, it stops, it is rational. The next one is 2 times the square root of 7. Well, we know that the square root of 7 is irrational because the square root of 7 is a non-perfect square. There is not a whole number that multiplies by itself to give you 7. So it does not matter. Even if you take any number like this, so if I take 2 times the square root of 7, I would have 2 times 2.645 ... It's going on forever and it's not repeating. So even if I'm taking 2 multiplied by an irrational number, I would still get an irrational number. The square root of 28 is also irrational because if I figure that out in my calculator, it's a number that is non-terminating and non-repeating. It goes on forever, and this is a non-perfect square. Square root of 14 is also irrational because it is a non-perfect square. And if you're unsure what I mean by perfect square and non-perfect square, be sure to ask your teacher at this time. If I take the square root of 1 over 16, remember that's like just taking the square root of both of those values and dividing them. So the square root of 1 is 1, the square root of 16 is 4, and if I take 1 divided by 4, or 1/4, is 0.25. Since that decimal terminates, it ends, it is rational. The next one is 2.45455. This does not have a pattern. It is not repeating. And it does not have a ... after it. So this decimal terminates. It ends, so it is rational. Number 11. 2.45454545. Since this is really 2.45 repeating, remember all repeating are rational. Think they both begin with an R. Number 11. 2.454554555 ... Well, we see that this number goes on forever, so it is non-terminating. And this number is definitely not repeating because it just doesn't go 454545. So non-terminating, non-repeating are irrational numbers. Number 12, 2.45545554555 ... Well, this is non-terminating because it's going on forever. However, it is also non-repeating because it's not just repeating the specific pattern. So it is irrational as well. So just to reiterate what I've already talked to you guys about is, remember, rational numbers, they terminate. I'm just going to squeeze that in there. Remember, terminate. Think of the terminator, it stops, or they repeat. Irrational numbers go on and do not repeat. So remember, irrational are the non-terminating, non-repeating, non-perfect squares. Rational are all whole numbers, they're all perfect squares. What I'd like you to do right now is, I'll do A with you. So it says 3/12. So if it were me, I would simplify if I can. So 3/12 actually simplifies into 1/4, which is as a decimal is 0.25. Since that number terminates, it is rational. So I'm going to say R for rational because it terminates. What I would like you to do right now is you are going to try the rest of those, A through U, and then once you are done trying them, you are going to check your answers with what I have. You're going to press play, check your answers. If you are not understanding something, please ask your teacher. And when you have A through U completed, check your work and let us know if you have questions. So you can press pause now, and then once you're ready to check your answers, please press play. Alright, so if you want to start checking your work, I have the answers here. Everything in light blue are rational. So for example, B is rational because it terminates, and this is also, you can think of it as a whole number. 10 is a whole number. C is irrational because it goes on forever without repeating. D is rational because that repeats, 3.14 repeating. E is rational because that decimal terminates, it stops. F, rational. G, rational because it terminates. H is irrational because it's a non-perfect square. There's not a whole number that multiplies by itself to give you 19. I is irrational because it's a non-perfect square. There's not a whole number that multiplies by itself to give you 32. J is rational because 6,000 divided by 1 is just 6,000, which is a whole number. K is rational because it terminates. L is rational because it is a whole number. M, square root of 64 is 8. It's rational because it's a perfect square. N is rational because it repeats. 0.1 repeating is the same as 1/9. O is rational because it repeats, because 777.7 repeating. P is 0, rational. Q is 4.5, which would be rational because it terminates. R is rational. S is rational because I would have a whole number. T is rational because if you do all the math, the square root of 6 squared plus 8 squared would be 68, which is rational. And U is also rational. So right now I just want you to think about rational and irrational and remember the difference. And if we go back to the very beginning, you can see the difference. Remember, for the big picture for this lesson, irrational numbers are non-perfect squares. They go on and on and on and do not repeat. Rational numbers, they terminate or end, or they can repeat. And these are also perfect squares. You could also think of rational numbers as whole numbers. Those are some more examples. I hope this helped you. Like I said, if you have questions, ask your teacher, but if not, you can log into Schoology and take the quiz that is labeled rational and irrational numbers. Thank you so much and have a wonderful day.